starting informative speech for Alexandria Westoy Mycoremediation. This is the audience. And then all right. So okay. Environmental contamination is posing a serious challenge, from industrial waste and oil spills to the devastating effects of long-lasting radiation. Current cleanup efforts are labor-intensive, costly, and they produce just as much waste as they clean up. While many efforts have been made to contain these environmental hazards, often these methods only lead to a way to trap, transport, and contain these substances. One potential solution to this cycle may lie in the silent, oft-overlooked organism, fungi. Today, I will elucidate the key role that fungi have and should play in environmental remediation efforts, a process now known as mycoremediation. After coming across the book Entangled Life by Merlin Sheldrake a few years ago, I became fascinated by how crucial a role fungi hold in our ecosystems and how often left out of conversations about ecosystem viability they are. Determined to learn more, I have researched this presentation. Now I can share what I have learned about the specific ways in which fungi can and do help keep the world in balance. These fungi can not only absorb the pollutants I have mentioned previously, but they can help break them down and transform them into harmless or beneficial matter and materials. Given that this pollution as it stands impacts human health, food, water, and air quality, it can be pertinent to understand this new sustainable approach to pollution cleanup. Mycoremediation is best explained starting from the ground up. First, I will give a brief overview of how mushrooms function, and then I will move on to show how these functions can be applied to the tough environmental pollution scenarios we are facing today. Then I will give examples of how these fungi are working to improve human quality of life through cleaner soil and water. Finally, I will address the potential for these fungi to work on a larger scale to clean up irradiated zones and the larger implications all of these projects could have for our environment. Mycoremediation uses the natural enzymes produced by fungi to break down pollutants and transform them into harmless byproducts. Fungi secrete enzymes that degrade complex compounds, toxic and benign, into simpler forms. Some of these byproducts are used by the fungi to complete its life cycle, while others are released back into the environment. White rot fungi, for example, release enzymes capable of breaking down lignin, the tough component in wood. This capability allows them to degrade similar chemical structures in things like industrial waste from paper mills and paper pulps found in wastewater. The enzymes are versatile too. According to environmental scientist Paul Stamets, fungi like Pleurotus ostreatus, also known as oyster mushrooms, can decompose hydrocarbons found in petroleum, converting these contaminants into clean water and carbon dioxide. Unlike chemical or traditional containment remediation methods, mycoremediation relies on fungi's natural metabolism. This requires no harmful chemicals and poses minimal disruption to the ecosystem they are a part of. Traditional cleanup methods can often introduce secondary pollutants or harm local plants, animals, and microbes. Fungal remediation, by contrast, gradually neutralizes pollutants through naturally occurring processes like enzymes and encapsulates them in a way that they can be removed with little to no harm to the environment. Now that we know how these fungi work to break down pollutants, we can look at some examples of how they have been used to improve the soil, as soil quality has a direct impact on human life. Mycoremediation truly begins in the soil, where fungi, like the Pleurotus species, work to break down contaminants from the ground up. Soil contamination is a global issue impacting agriculture and productivity. It affects the quality of agriculture, generating a loss of productivity between 15 and 20% per year, according to Natalia Rodriguez Eugenio in a report released by the Food and Agriculture Organization of the United Nations. Fungi such as Pleurotus ostratus, commonly known as oyster mushrooms, could completely break down and digest anything from crude oil to cigarette butts. Oyster mushrooms not only decompose pollutants, but also absorb heavy metals from the soil, significantly improving soil quality and productivity. The fungal network operates like a sponge in the soil, drawing in and absorbing toxins, which are then broken down through natural enzymatic reaction, converting harmful substances into innocuous byproducts and helpful building materials for plants. It's not just soil that fungi can improve. Mycoremediation has demonstrated success in the remediation of oil spills and industrial contamination, underscoring its practical efficiency. Fungi has been employed to remediate oil spills where they break down hydrocarbons into benign components. In 2007, oyster mushrooms were used to treat oil-contaminated soil in the Amazon, reducing petroleum pollutants by more than 90% in mere weeks, proving an efficient solution to soil contamination. Additionally, mycoremediation of oil spills allows fungi to convert toxic hydrocarbons to carbon dioxide, water, and fungal biomass, showcasing a cleaner remediation process than chemical methods. Fungi have also been used to extract heavy metals from contaminated soil near waterways. A study conducted in California revealed that oyster mushrooms could absorb heavy metals like lead from polluted soils through a process called biosorption, thereby enhancing soil safety and fertility over time. This has helped mitigate runoff into local waterways, protecting drinking water and water treatment equipment from excessive buildup. Fungal species can accumulate heavy metals within their cell walls, where they are safely contained, reducing overall soil toxicity without spreading contamination. Beyond cleaning up water and soil contamination, fungi are even capable of tackling the special challenges of radioactive zones. Mycoremediation holds potential for radiation cleanup, a particularly challenging area of environmental remediation. Certain fungi can grow in radioactive environments, absorbing radioactive particles and heavy metals into their cells. In the Chernobyl exclusion zone, fungi like Cladosporium sphaerospernum have been observed feeding on radiation as a form of energy, illustrating their resilience in extreme conditions. This resilience enables fungi to absorb and concentrate radioactive isotopes, making them potential candidates for radioactive site cleanup. Some fungi can safely contain radioactive particles, making it feasible to remove and dispose of contaminated fungi without risking environmental exposure. Research from the Pacific Northwest National Laboratory has shown that fungi like Cryptococcus neoformans can bind to radioactive isotopes, thus isolating them from the surrounding environment and offering a safer route for decontamination. Beyond these successes, mycoremediation presents further possibilities for global environmental remediation. The future of mycoremediation suggests the possibility of far-reaching global success in environmental improvement if we encourage the fungi to develop in a variety of situations. Researchers are now exploring ways to engineer fungi that can target specific pollutants such as plastics and synthetic chemicals, expanding their utility. Merlin Sheldrake notes that scientists are developing superfungi strains designed to tolerate harsher environments and to target and break down difficult-to-control contaminants such as microplastics as their primary source of nourishment. Fungi are low maintenance, low cost, and in most cases require no cleanup after use, allowing them to flourish, decompose, and begin the cycle again as long as necessary. Environmental microbiologist Maria Becerra observes that once we can cultivate and deploy these fungi efficiently, they can be applied to large sites such as landfills, chemical spill zones, and mining areas, making cleanup both economically feasible and eco-friendly. Combined with the super fungi projects mentioned above, this could lead to the possibility of both reducing overall landfill size and allowing previously contaminated land to return to practical use much more rapidly than previously thought possible. In summary, mycoremediation uses the natural abilities of fungi to produce enzymes that metabolize all sorts of substances to decompose, absorb, and isolate pollutants. This is a new approach to environmental remediation that is low maintenance, low cost, and highly effective. From soil pollution reduction to oil spills and radiation cleanup, fungi have shown remarkable promise in a diverse array of applications. As soil contamination alone can significantly hinder agricultural productivity, improving soil quality has far-reaching benefits for health, food security, and the ecosystem. Fungi have been overlooked for far too long, as current methods of environmental cleanup fail to produce the results we need to thrive. Fungi can help provide the ability to adapt and overcome we need to remediate and even reverse environmental damage. That is the end of my speech.
All right.
Thank you very much for participating.
Right.